Now in the very first lecture of this section, we will look at what is a linked list. By definition, linked list is a form of a sequential collection and it does not have to be in order. A linked list is made up of independent nodes that may contain any type of data and each node has a reference to the next node in the link. I know you might not understand this definition from the beginning. So to make things more understandable, let's look at a real-life example. In real-life example, linked list data structure resembles a train. Because, as in the linked list, the train is composed of nodes, which are cars, and where there is a link between these cars over here. So you can easily see that this train is composed of several cars over here. In case of linked list, it's node, and there is a link between these cars over here. Another feature of trains that confirms with linked list is that both of them had head and tail. So in case of train, the engine is head of this train and the last car is the tail of this train over here. And we know that all these cars that we have in the train are independent. It means that if in case we don't need this compartment over here, we can always remove it and add new one and the train is still going to work. So that's why we can say that each car over here is independent. Another feature is that we can enter any of these cars in a sequential manner, which means that while train is going, we cannot jump from the first car to the last car. We have to go through these cars over here. So this means that we need to access the cars of this train over here while it's going sequential manner. So we have to pass through the other compartments to reach the last compartment over here. And as I mentioned in the definition of linked list, each element consists of two parts, which are the data and link to the next node. And here in train, we can easily see that in each car, there are passengers and each car is linked to the next car. So it can be easily seen that train satisfies all properties of linked list. So we can say that train is linked list. Now with this example, we understood the analogy of linked list. Of course, there are some properties of trains which do not conform with linked list. For instance, the train compartments are contiguous, which means that they are next to each other. But the linked list in memory is not contiguous. In the world of computer science, the linked list looks like this. It can be easily seen that this structure resembles the structure of train that we explained over here. So in case of train, we have head over here, and in case of linked list, we have also head over here. In case of train, the engine is head, and in case of linked list, first element over here is the head of linked list. And the next property is we have cars in trains which carry passengers, and in linked list we have nodes over here, and in nodes we have values. And we can easily see that these nodes are linked to each other with a link between them. And in case of train also we see that the cars are linked together with these links over here. So in case of linked list we have also links between nodes. And finally, the last node of linked list is called tail, because the pointer is null. There is no link to other nodes from this node over here. So if we summarize the components of the linked list, we can get following. As we can see from this diagram, the first component of the linked list is head, which has reference to the first node in the linked list, and there is no reference to this head over here. And there might be a question, why do we need head? So the answer is, if we don't know where the linked list starts, then how can we access the linked list element? So this is a must for locating a linked list. Then we have nodes, which are the elements of the linked list. Nodes consist of two parts, so in the first part we have the value of node, and in the second part we have a reference to the next node. Now in case of first node, we see that we have a reference of 111, which is the physical location of the second node. You see that second node's location is 111. So this means that in the first node we have stored this reference to access the second node. So the data in this node can be any data type. It can be integer, string, and so on. Now you might be interested what is the data type of the reference over here. It's basically physical location of the nodes in the RAM. So as I mentioned, the physical location of second node is stored in the first node, and the physical location of third node is stored in the second node, and the physical location of fourth node is stored at the third node. Then it continues like this to have a link between them. So when we visit the first node, we know exactly where the second node is located based on the reference we have stored in the first node. So the last component of linked list is tail. which is a reference to the last node. So here, basically, we store the physical location of the last node. So here again, you might be interested why we need to store this reference. Why do we need tail? So if you want to insert an element at the end of linked list, without tail, we have to traverse all these nodes and come to the last node and insert a node over here. And this will take O(n) time complexity. But by knowing the last element's address, we can increase the efficiency of the inserting an element at the end of linked list. But the tail in the linked list is not mandatory. So this is for just increasing the efficiency of linked list. Okay, with this we have come to the end of this lecture. So here we have explained what is a linked list. So hopefully with this real life example, you have understood the main components of linked list. Now in the next lecture, we will talk about the main differences between arrays and linked lists. So see you in the next lecture.